Ooh, works.
Well, there's trans species, so there's a trans cat. And then there's trans age. I'm a 4-year-old girl, but I want to be.
Hey, Mr. Miller.
Yes, sir.
Why did Sean Ramos call you Mr. Robin?
He calls me Christopher Robin all the time.
Really?
Yes.
This probes are putting
What?
my notepad book over there again, just whatever.
And what's missing?
Alright, welcome everyone to Wired Network Security and What's Missing. This is actually a previous presentation that I've done before, although it is the condensed version. I had to take a whole bunch of stuff out to fit this into a 1-hour time slot because it used to be a 2-hour thing that I would go into all sorts of different material and things. So this will be kind of fast. For that reason, I do ask that everybody hold questions until afterwards. If you got them, jot them down or whatever, ask me after the actual presentation. I'll answer them as best I can. Precursor to this as well, I'm going to show you the network that we're dealing with. I do have a couple of an actual hardware setup for this. It's really, really simple. I've got an 1841 sitting under the projector here and a 2950 under it. And I've got it in a fashion like this. A Linux laptop here, it's a DHCP client. It's actually going to be doing manual static IP address of 1N21state2.253 on the switch and 1N21state2.254 on the router that we're doing. Similar setup, we have just a /24, similar setup to what we have in the CCNA4 class right now. Last usable for the router itself, second to last usable for the switch, and that's just VLAN1, default, everything, just a regular piece there. So, now, that being said, me explaining this, I now am going to forget all of this. I am a hacker coming into the network. I don't know anything about this network yet. So I will now forget everything that I just told you. And we'll talk about the how to find out that information specifically. So, prelude to this. I do have to put in a lawyer clause for any of this. This is entirely illegal if you do not do, or if you do any of these things on a network that you do not have the rights to. If I catch anyone doing any of these things on this network or any other that you do not have permission to do so on, I will personally make sure that you get thrown under the bus, either by me or my crew or whoever I need to. Do not do this on something you don't own. You can do this completely for free, all within a VirtualBox client. You can actually make a virtual network with all of your hosts and everything. It doesn't even leave your computer. Or you can buy an 1841 for like 20 bucks on eBay right now and 29.50 for almost free. That entire setup right there is probably available for 30, 35 bucks shipped on eBay right now. And stuff's really, really cheap if you want to try these utilities out. And the actual Linux applications that we're using are completely free. I'll tell you about a distribution here shortly. You can get these things on very, very cheaply. It's really, really easy to get this stuff in place. Now, what is a hacker? Way back in the 90s, when the computing networks weren't really very prominent, we had the term hacker and then we had the term cracker. These were not synonymous. Cracker was kind of the evil, I break into stuff kind of thing. Hacker was the person who figures out different things. So we look at the design of something and how that something works, and we use the utilities that we are given at our disposal. So I see a computer that has lots of hardware within it. I don't see an operating system or software or what have you. I see a computer. I see the actual hardware devices that are capable to me. That is the actual definition of hacker. However, the world has kind of changed that. Nowadays, the term hacker is ubiquitous enough that hacker just means you're breaking into stuff you shouldn't be breaking into. So that is basically those pieces. Now, way back when I was in college here, we had a running joke, because every time Cisco would talk about hacking in the CCNA security course, it would be a guy in a black hoodie that was like hunched over a laptop, and that was like what a hacker was supposed to look like. So we used to always joke around, and I wanted to keep that whole thing going. However, if you search Google Images right now for a hacker, you get a guy in a ski mask coming out of a laptop for some reason. So, according to Google Images, that is what current hackers look like nowadays. So be on the lookout for anybody that has a ski mask and business casual working on a laptop, because that guy's probably not to be trusted. Now, hackers are separated into 3 different categories, and these are categorized in hats. We have black hat, white hat, and the ever popular gray hat. Black hat is kind of the sounding of this. This is the evil hacker. They break into stuff, usually for personal gain or business gain, something like that, without the permission of whatever they're actually breaking into. White hat is exactly the opposite. I may break into something and tell a company about something, or get a software implementation fixed in, or maybe I'm doing it to my own company to make sure that other people can't break in, that sort of thing. That's usually a white hat's job for this. I fall firmly in the middle somewhere normally. I'm usually a gray hat hacker. I do this conceptually. I have fun with the work that I find, and don't usually do anything with most of the information that I find in different things, different places out in the field. Now, obviously, you guys are mostly part of the CCNA security course. Why learn this stuff? Because this is the stuff that people are going to be doing on your network, or attempting to do on your network. You've already learned about how to kind of thwart these things, but you've never seen these utilities actually used from the other side of the fence, from behind the hacker's eyes, or behind the hacker's fingers in these things. We also are not going to be using any GUI tools, and I do this so that you understand the underlying process of what goes on. There's a big trend in GUI tools of hacker things that essentially do everything for you. You click a button and then all of a sudden your entire network is arc poisoned. I don't like that. You can't actually see the entire process for what's going on. By not using GUI tools, we understand this whole thing a little bit better, and we can hopefully kind of dissect it a little bit better as network people, because we understand these individual processes anyway already. I am going to be using Linux almost strictly for all of these things. There are a couple of Windows utilities for what I'm doing, but Linux allows us the freedom to do all of these different hardware pieces. We don't have to worry about Windows restrictions on different hardware drivers or what have you. Linux will give you enough rope to hang yourself and hang your neighbors if you want to. So we need that kind of rope. We're going to be using Linux for everything we have. There is a disclaimer. Linux does not work with all hardware pieces. And actually an excellent example, in order to boot my laptop correctly, it actually has to PXE first, fail PXE, and then boot to the hard drive. It's just a weird thing that Linux has to do. And some things, you may not have network drivers, you may not have correct video drivers, you may not have any kind of RAID drivers on what you're working on. So just keep in mind, Linux does not support all hardware that is available. Now, everybody here has had me as an instructor at least once. You know that I ramble or stop making sense or something like that. However, since I'm on a time crunch, I'll probably be working through this stuff pretty quickly. So hopefully I won't ramble too much with a lot of this. Now again, I had to take a couple of things out, but we're going to go over the basics of wired networking, what happens when I plug into a network, preparation of the actual distribution that we're going to use, although that's really quick because I'm using a custom one that's already on. We're going to quietly explore the network with a little bit of basic network scanning. We're going to talk about exploiting the easy stuff, although we won't look into it too much because I custom set some of this stuff out. The easy stuff isn't really going to work. Now we're going to get a little bit noisier on the network. We're actually going to do some actual network scanning, some big network scanning, as well as looking at MAC flooding. And I've got loopback plugs on our actual switch that act as dumb layer 2 clients so that we can actually see MAC flooding works. It works on this switch, thankfully, so I tested that earlier today. Then we're going to brute force with specifically Hydra. John Medusa and Encrack are all other utilities, but I will be using Hydra for this implementation. And then real quick, we'll talk about a DOS. Denial of service attack. We'll probably do a directed denial of service attack against one of these, but probably won't let it run for very long. I'll just show you how some of that works. This is a bunch of different types of things. And at the very end, if I've got time, I will talk about physical security aspects, and there's a video that I want you guys to see on some of the physical things. Because again, I think that's something that's important from a network security aspect. You be aware of physical methods into an actual network. Physical security is something you need to think about as well. Now, layer 2 connection. Before we even worry about IP addressing, what happens when we plug in to an actual network? We begin responding to frames immediately. We don't have an IP address at all. We can still communicate on a layer 2 network. However, this is almost never used. We can technically communicate without an IP address on a local network only, just by using MAC addresses. But any modern communications, we're going to need an IP address at some point. So we're going to move up to that layer 3 connection to actually have that work, so we can communicate on a modern network, or on an actual network, the actual network. To get the layer 3 aspect going, we initiate a DHCP discover from the client itself. The server sends a DHCP offer. We acknowledge or we request the IP address that we were offered to us by the offer. Server sends us a DHCP ACK and says this is now your reserved IP address. So it's kind of a 4-step process that happens to actually get a DHCP address. ARP is then used to translate an IP address into a MAC address. So now if I want to do local communications, if I want to talk to an address or a MAC address on my local network, and I have the IP address, I send out that broadcast, that ARP request to find local MAC addresses out on the network. That is very common, and actually part of my presentation that I took out is ARP poisoning. get back into that later on in the semester probably, so bring all of those out. ARP requests are made to discover all of the other IP addresses on your local network. ARP does not move past your actual layer 3 information. So as soon as you hit a router, ARP stops. We don't have any physical addressing information for that next hop over. ARP, however, is the bestest thing ever for us network security people because it's such a simple protocol. It's really easy to break that protocol. There's not a whole lot that you can do to safeguard your network against a good ARP attack. So once we get into the ARP pieces, we'll talk about it later on in the semester. ARP is a really, really cool thing. I'd like to spend an entire day talking about all of that. Now, preparation for this. Again, we are using Linux, so we're going to boot the distribution, become root if we are not already. We need a root terminal for this or an admin account on the Linux system. Disable any network services depending on what you're running on your distribution. This could be lots of different things. Essentially, we want to get rid of anything that's going to be doing any kind of network communication without our knowing or before we tell it to actually communicate on the network. For Kali, which is the distribution that I recommend you guys do, I think it is still /etc/init.d/network-manager stop, but they may have moved to systemctl by now. Systemd is kind of going away, that whole process of this. So one of these commands will work in Kali. Mine is actually completely separate, and I can skip this altogether because I have this set up in a custom way that doesn't actually start this manually. This one's made specifically for doing these sorts of things. And then we need to identify our network interfaces. What is the name of our physical network interface that we're going to be using, just so that we know where it is. If it is a wireless device, we want to put it in monitor or promiscuous mode. Basically, do not respond to anything without me telling you to respond to that information. For a wireless device, that is Airmon-NG, which is a wireless piece that we'll go into in another presentation as well. But we're doing wired network today, so we don't actually have to worry about any of that. The basic goal here is to make sure that nothing touches the network before we tell something to touch the network. Again, we're starting off in the quiet area. We don't want to start broadcasting that we're here and that we want an IP address and all of these things right away. We want that to do that in a controlled fashion for that. So, with that said, let's actually boot this distribution. And again, I have this basically set up already. This is a custom version of Arch Linux, but you can think of this as any network security distribution. Mine is just a little streamlined, and it's only got the utilities that we're actually going to talk about, so it ends a little bit faster. I have a network management application up here on the right. If I click on that, I should, I'll plug in a cable. That's why you test these things beforehand. If I plug this in, I should then get the option for DHCP. So I'm not actually DHCP yet. I am doing layer 2 communications because I see that connection there. I've brought that layer 2 connection up, but I haven't actually asked for a DHCP address yet. This is exactly what you want from a penetration testing standpoint. You don't want to be seen on the network until you absolutely have to. And I would even go one step further, as opposed to turning that monitor mode or promiscuous mode on so that they don't even see your MAC address. You just start looking at information. That's a little bit harder to do quietly. Once you get an IP address, they pretty well know you're there. So since we're skipping the ARP piece, since we're starting immediately with network scanning, we can go ahead and get a DHCP address. While that runs, because in 1841 takes forever for some reason, let's get sudo is normally the command to gain root access, and sudo is to run a command as an administrator. And then su stands for switch user. And by issuing sudo su, I'm switching to the user root and doing that as an administrator. So sudo su is actually running as an administrator and turning me into an administrator. So now I am root. I am the admin on this PC. Now I can actually run these utilities that I need to run. And then eventually I'll get a little notification up here that says that I have an IP address. Obviously it's taking forever. Eventually. Now you will see blinking and stuff up on this switch up here. Again, I have a couple of loopback plugs in place so that we can get communications through this, because we will be doing MAC flooding. It should work. And hopefully we get everything in place well enough to actually get this stuff working. We'll see. And hopefully that DHCP address works. Worked earlier today. So, distribution has been booted. Now we want to look at actually looking around on the network, or scanning quietly. Because again, we don't want to necessarily make our presence very known yet. We want to be at least as quiet as we can be, at least in the beginning, so to speak. Nmap is the application that we're going to be using for this. And Nmap is probably the best network scanner around. It is the certainly the de facto standard for doing any kinds of scanning applications like this. It's a big application, or sorry, a small application, but it's probably the most common and most used in the hacker community for any kind of network scanning that you do. Nmap is so awesome that it also has a Windows version. However, it is a little bit scaled down. There's a lot less functionality in the Windows version because Windows puts a lot of restrictions on the different things that we do. Their site, sechtools.org, also has a huge list of network tools. They're so awesome, and they know they're such an awesome utility that they have the top 100 network security tools, and they leave themselves off of that list because they're like, we know we're at the top somewhere. And they just, here's the 100 that aren't us. And they categorize those into different sections so that you can kind of pick out what utilities you need out of those different pieces. And ZSH or bash completion come in handy. That allows us to tab complete within operators of the piece, giving us kind of a Cisco-like environment. For the commands that we're doing, it's not actually necessary. We're not going to be doing too many arguments on a lot of these. The basic command is nmap, and then we have switches past that. -SP, little s, big P, these are case sensitive. That is a basic ping scan, so we're essentially going to ping the entire range of networks that we give to the host. We will then give a network operating statement past that. So what do we actually want to ping on the network itself? SL will use DNS queries, so if we have a larger network that actually has DNS flowing around the network, we can slowly gather all of that information and get those DNS queries into kind of a host file of sorts. We can then look at the names that have been resolved to IP addresses. For such a small network like this, that doesn't work. But for production networks, this works pretty well. You see all of the local computers around you pretty quickly, and since you've quietly gathered that information just into a cache file, you're not actually even scanning the network, really. You're not asking for different entries around. So this is actually really, really quiet on a production network. And SP-F, which is probably what we'll do, is the same ping scan, except that -F adds fragmentation into it. And rather than sending one ping in a single packet, we're actually sending one ping across multiple packets. So we send the first half and then the second half, and then it reassembles on the other side, and it doesn't exactly look like a ping. This will confuse a lot of intrusion prevention and intrusion detection systems, because we don't have an actual ping that's going across. We have fragments of pings, but they're still reassembled and turned into ping messages once they get there. It's one of my favorites, just to add fragmentation on things, because it works with almost every nmap command we have. Once we have a few hosts of interest, we can then scan more selectively for what we actually are looking for on a system. If we have the list of IP addresses that we have, say it's 192.168.1.1, 110, 109, and 1214, we can then specify these in a nice little comma-separated format. If we specify the F, again, that's a fragmentation scan. If we do not say what kind of scan we do, Nmap will go through and it will scan for 1,000 of the most common ports available. That's not 1 through 1,000, because they pick a couple of random higher ones as well for known services that people are kind of looking for. So it'll do basic things: HTTP, Telnet, SSH, HTTPS, all those applications that are normally running on servers and things. The basic scan will look for all of those. The same scan here, except we add -O, capital O. That gives you the OS detection aspect. So it'll kind of poke at each of those hosts and see how they respond to different pieces of information. Based on how they respond, we can guess what kind of OS they are. Newer versions of Windows will actually tell you what kind of OS they are, or what version of Windows they are. So they're really nice for things like that, because we have automatic network sharing resources and things that happen on Windows networks. So very common for Windows to go, hey, I'm a Windows 10 system. I got this cool new software. You want to try it out? We're like, nope, we're not Windows at all. Thanks for letting us know what kind of version of Windows you are. So that kind of stuff is really helpful as well. A little bit more noisy, obviously, because you're poking a little bit more of the system, but for basic scanning, you usually won't throw anything out. Remember to record anything of value that you find. So I'm going to be opening a notepad document, kind of recording some of these things as we go, although we don't have a whole lot of services on these. Know your common ports. Nmap will tell you this is SSH, this is Telnet, this is blah, 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 but you can't necessarily specify the individual ports as SSH, as Telnet, as whatever. So know that HTTP is 80, know that Telnet is blah, blah, blah. So know your actual ports. Back when I was a network engineer for the university, I used those daily when I was looking at different clients and things. If we had hosts on the network that were using more network resources, scan those and figure out what the heck port is that, or oh, that's a web server running on something for some reason, running HTTPS, or why is it running HTTPS, etc. So make sure that you know the common ones, the basic ones, at least for basic functionality. You don't have to reference a paper all the time. Nmap also has a GUI version called ZenMap. That is actually the basic thing that's included in the Windows version. They also have that Linux version available, but for smaller networks like this, it doesn't really make a whole lot of sense. ZenMap makes sense when you're trying to map an entire large network. And the command structure is really difficult to deal with ZenMap. So we won't look at ZenMap today at least. Now let's scan some things. However, I'm still fighting with this DHCP thing, so I may actually have to look at my router. Oh no, here's why. My router's empty. Hang on. That's I've got a basic paste config in here. This is why you save all your configs. There we go. Hey, there we go. Now I've got it DHCP and everything enabled shortly, I guess. And all right, give that a couple minutes to start doing things, and then once I DHCP, I should then have an address. Hopefully.
What distro is this in?
Make sure. This is Arch Linux. Arch Linux does not give you any kind of GUI immediately. It's not for the faint of heart. This starts as a command line, and you put every individual thing that you need there. I've been using this distro for 8 years, something like that, so I'm pretty well versed in this. I would recommend starting out with Fedora or Debian or Ubuntu or something similar, a little bit more user-friendly that way. There we go. Now I actually have stuff. If I hover over this, I can get my DHCP active piece. But again, we need to find out some basic information about things. Look at the actual network at hand. We now have an IP address. We can get our subnet information, figure out how large that network is, and then start scanning around on the actual network. First thing I'm going to do is open a notepad document, maybe. There we go. Mousepad. It's just a basic notepad thing so that I can type some stuff, get some extra notes in here and things. And I will, let's do nmap-help. Oh, nmap, equals nmap does not work. Command is nmap, there we go. Nmap has a huge list of operators. This is a gigantic list of different commands and things that you can have. These are kind of separated out into sections, which is kind of nice. Most of the host discovery things are what we were actually talking about. So we have that ping scan that we talked about, and this is actually an alias. We have SN that they've changed to more recently. But an SP is the same kind of deal, just a basic ping scan. We've got a PN that actually pings all of the initial IP addresses, not just the ones that it thinks are online. All sorts of different things. But we're going to start off with this basic ping scan. However, in order to scan the network, we need to know what kind of network we're on. So how do we figure that out? The command for that is ifconfig, and that'll get us basic information about what our network interface is. In this case, mine is named ENP6S0. I talked about finding your physical network interface. That is my physical network interface. And I have my internet address, or my INET address, is 192.168.2.1, and my net mask is 255.255.255.0. That's why I hammer subnetting on you guys so much, because very seldom will you get an actual /24. In which case, if you got a /22, you should know the entire range of that network. You should be able to figure out the actual range piece of all of those pieces, so that we can actually specify that in CIDR notation instead of specifying the whole the whole subnet mask. It's a little bit easier that way. So now that we know 192.168.2.0 and it's /24, that's very easy to figure out. That is 192.168.2.0/24 is the entire network statement. Obviously, if that were a little bit different, you'd have to figure out what the actual network is or how large the network is. So let's see what we can find. Let's do nmap. I can't actually see what I'm typing on this screen. I have to look over here, so it's a little strange. 192.168.2.0/24. And again, this is just a basic ping scan, nothing special running on this. It's just going to ping each of those individual hosts. I don't believe, nope, it's not even going to do any service scanning yet. This is just to get us what hosts exist on this network. In this case, we have an nmap scan report for 2.254, 2.1, and not 2.253. I wonder if I didn't config that one either. Let's see that real quick. Let me block this right quick. This is what happens when you don't save your configs. So we should have a 2.253 here as well. Nope, it's there. It's just not actually responding to anything, which is nice, because that means that it's a little bit more secure. That's good. We don't actually know that 2.253 exists from the scan, but it is there. So we'll have to do a little bit deeper scanning to actually figure it out. Let's move this back to my router here. So from this, all we know that exists is 2.254. We don't actually know anything about that host, so let's see if we can figure some things out. Again, if we add that -O in this, we can figure out the actual operating system, or it'll try and figure out the operating system. And again, it's just going to poke at that host and ping it a couple times and see if we can figure out what operating system it's actually running. See how much information we can actually find. I didn't actually do this, so we'll see how much information it actually pulls from this. This is an 1840 run running iOS 12.2 or 12.3, I'm not actually sure. So we'll see how close it actually gets. And there we go. It is a Cisco 800 series, 1801, 2000 series, so it's guessing, it's giving us a range. And it says iOS 12.2 to 12.4, so somewhere in there. Not an exact piece, but that's plenty to go on if we can figure out the actual services that we have on this. Right away, we know that it is a Cisco thing. We know what kind of software it's running. We know it's not iOS 15. And even 12.4 is like 9 years old at this point, something like that. So surely there's an exploit or something that we can figure out on that. So just from a basic operating system scan, we can figure out a ton of information from what's actually running on this system, or what is capable of being done on this system. Now that we know that piece, and actually, the scan actually gives us, we also have port 22 open, which Nmap tells us is SSH, although everybody should know that, right? So we have SSH available on this system. We don't actually have 2.253. We'll find that in a later scan as well. But let's also scan, since I know that it exists. Let's do Nmap 192.168.2.253. Got that right? Excellent. Again, it'll take it a second. I didn't do any OS scanning, so it should be a little bit quicker, hopefully. Get us some services. There we go. So we have Telnet and HTTP available on this individual system. That would absolutely be the first thing that I hit. HTTP is really, really simple because not encrypted at all, and it usually doesn't require any login, depending on what it has. So as a penetration tester, that would be absolutely the first thing that I would go for. And so I see a web server on something, that's what I'm going to attack first. So keep all of these things in mind. So we take all of this stuff back to our little notepad document. We've got 192.168.2.254, and it has SSH, which is 22. And then we've got 192.168.2.253, and it has HTTP, which is 80. And again, that's my super awesome, cool one. We'll see if we can do anything with that later. And then we've got Telnet on this, which again, is pretty cool because we probably don't need a username or anything for that. That is 23. So we've got these two hosts, and actually, let me make that a little bigger. We can actually see this information. We're not going to get a whole lot of extra piece in this. Size 0 font, that's perfect. It's nice and visible. Come on, really? View, font. Looking gigantic. Why you know gigantic? You know what? It's for you. What else do I have on here? There we go, text editor, that'll work. Do something else. V. There we go, a little bigger, and I can probably make this even bigger. Oh goodness. There we go, much better. So now, I've got all of my information that I just found out, which isn't very much, but I've got all of it figured out and put in a notepad document. I'm also going to put Cisco on here, although that's not really relevant, so we're not going to do anything specific to Cisco. But if I were actually looking at this device, I would absolutely make sure that I remember that that is a Cisco device, so we can get some of this figured out. So good, now we have basic information about this. Let's see what else we can get on this. Let's see how much further we're making it. Done scanning networks. Now, the easy stuff, I'm going to skip over all of this, but at least talk about this real quick. You would be surprised how many people leave everything default. I cannot tell you how many default passwords I've found out in the field. There are a bunch of online resources for this. Team SID releases, I don't actually remember the company that does all of these, but they do the 25 worst passwords every year. That they actually come out with the worst passwords or most common passwords that are around. 1, 2, 3, 4, 5, 6, and password are always at the top of this list. That is the first two every single year that I've seen this list released. So those kinds of things are really, really common, and again, you would find a surprising number of devices for all of these things. SSH, HTTP, Telnet, FTP, all of these services can be left default passwords. We won't actually touch on social engineering, however, it is probably the biggest thing to get on. A well-versed person can fall for all sorts of different things, or can make someone else fall for all sorts of things. Back at the university, we had a bunch of doctors. Every single time we had a phishing attempt, some Indian guy would call in and say, hey, I need you to reset your password. We had 2 or 3 doctors every single time. They would, oh, okay, I'll click on whatever the heck you want. And then their account would get compromised and all sorts of bad things. You have no idea how stupid people are out in the real world. It's tons and tons of people fall for that sort of thing. A well-spoken individual can get more from a phone number than they can from an actual host name. You can get a phone number of the IT person with a simple who is on Google. So who is mst.edu or who is statetechno.edu. That'll get you the phone number of the IT person, and that's plenty. If I say, hey, I'm calling on behalf of Mike Pruitt, the IT guy at your school. And, oh yeah, I know Mike Pruitt. You're calling on behalf of him. Cool. That is plenty of information to get by, especially if you know kind of how to get around your situation. If you've ever done any kind of prank calling, it's very similar. You just make stuff up as you go and see how much information you can actually gain. Really, really easy to do. Unfortunately, sometimes all of the easy stuff is covered, and we have to actually be noisy about what we're actually doing. So how do we actually be noisy? Let's look at some actual network scanning that's noisy instead of the quiet stuff. Again, Nmap is still the best thing, and there are some very aggressive scans that we can do. By default, Nmap will only scan 1,000 common ports, and those basic ones that it sees on most things. Most of the time, that's fine. What if you have some weird custom application that you're running within a business that some guy in the back closet somewhere has hacked together and made work? Probably got some kind of weird service running on a port that's not actually known. So Nmap won't do that by default. So we might want to specify some more ports. The Nmap-A command will actually scan, detect the OS, version detection of any software that it finds, and it'll implement a trace route, all with that little -A command. That is pretty aggressive because it does all of those things in one simple fell swoop. And every individual service that it finds, it will ping that service and see if it can figure out what version of TFTP they're running, or what version of HTTP they're running. So if they're running an outdated version of Apache, and we know that based on an Nmap scan, we can then issue an exploit based on the version of Apache that they're running. That's why you update your software. Nmap-P will specify whatever ports you want. You can do 1 through 65535, which is all of the actual ports, or you can simply do a dash, and that'll do every single individual port. Keep in mind, 65,000 is a really big number, and that'll take a long time, especially on a production network, to actually get all of those scans. And if they've got any kind of intrusion detection system in place, that'll for sure get you found, because you're port scanning the entire range of ports for an individual device. That's super, super obvious on this. Nmap-SL is a zombie scan. These are really, really cool. It's actually called an idle scan, but an idle scan is totally a lame name in comparison to zombie scan. This is actually really, really simple. So we send a basic request with a spoofed return IP address. If you think of the TCP three-way handshake and how the three-way handshake works, zoom in. I want you to zoom. Oh, you know zoom. Zoom. There we go. So we have SYN, SYNACT, ACT, right? Three-way handshake that goes across. So essentially, we send a SYN with a spoofed IP address that is to the person that we actually want to scan, and we spoof that return IP address as us. So essentially, we're man in the middling with a server that is none the wiser. So we're making a personally crafted first handshake. That first initial handshake is personally crafted. It goes to the initial server. Server sends a response to this guy with a source IP address that is incorrect. It's actually coming from this guy. And then this guy will actually respond directly to us. So we're scanning through an initial server. This can get around most basic ACLs if you don't have anything intelligent in place. This will actually jump around those things. Say you have access to the router on your public Wi-Fi, and your router on your public Wi-Fi has access to your servers back in the server room. You can actually scan through the router on your public Wi-Fi if they have any kind of TCP services in it. Really, really cool stuff. We won't actually look at that because that is just that one command, and we're way too simple to actually see any of that in place. But really cool scan, and it's actually really, really basic, implementing something based on the TCP handshake. That's why I like the fundamental stuff. It's really cool. Nmap is severely useful at this point, especially with larger networks, because visual mapping may be helpful. Depending on what kind of network you have, if you have a flat network similar to this one, where you don't have a whole lot of layer 3 devices, it won't give you a whole lot of information. You'll just have a whole bunch of hosts on the same network. But if you've got a really big network that's set up complicated like, it'll actually essentially map the network out for you with all of your layer 3 devices and where those devices reside, based on the trace route information and everything you had to get to those different devices. Running LLDP, which is the open version of CDP, or CDP can get you some helpful information. Loki can be used to attack OSPF routes, so it essentially runs OSPF on an actual computer, and you can listen to OSPF statements about other networks around. That is severely helpful because normally we can only see our local network. We can't actually look at other networks around. So that's really, really helpful, especially on larger networks because almost everybody uses OSPF. If possible, use Loki and CDP to try and branch out to adjacent networks. LLDP is another common one that you'll see on not Cisco networks. If you can get any kind of other information from other networks in the area, try and branch out to these other things. But keep in mind, this is the noisy aspect. If you're trying to bounce through different networks and do different things, that gets really, really noisy. That's, again, kind of where your zombie scan comes in, because you kind of want to use your gateway to get through those other devices. So you don't have to worry about your access loss quite as much for a lot of these things. if at all you get the opportunity, create a backdoor in whatever you can. Again, you should not do any of these on a production system, but I never use the first thing that I find as that's what I'm going to actually use. I use that first thing to create something else, and now I have a whoopsie, I got caught, or whoopsie, I need to get back in later. I have this thing that I created. So create a local user or a separate SSH connection or something that I can utilize later on to get back in if I ever get locked out or get automatically booted from the network or what have you. So do something to actually make sure that you can get access back to that spot where you were. So let's look at some of these. We're just going to do some basic port scanning. And again, we won't find a whole lot of different things, because we already kind of looked at the services that we have. But let's look at what these look like. That was the wrong button. There we go. I can figure this whole computer thing out. Now, let's see. We have the 3 services that we found, but what if we had other services that were available, like CDP? CDP is certainly a service that's probably running on that 1841. Let's see if we can actually find out if something like that is running. The command for that, we specify a specific IP address or a range of IP addresses if you wanted to do a bunch. And again, we specify little p for ports, and then I'm just going to do all of them because it's a relatively simple network. I'm just going to look at all of the available ports on that system. So it's actually going to go sequentially. Is port 1 open? No. Is port 2 open? No. It's going to go through all 65,000 ports. Again, on a production network, this would take forever. But with it being just 2 steps away from a switch to a router, should go relatively quickly, although you'll probably see a speed difference in between what we did. We only scanned 1,000 before, and it took us probably 10 seconds. This will probably take a minute or so to actually run through and get us all of those different ports. So really cool stuff. While we're also looking at that, what else do we talk about? Let's do the nmap-a. We'll open a new tab, and we'll do nmap-a against the switch now. So let's do 192.168.2.254. And that'll get us, again, OS version, or OS and version of the OS, and the version of any software that we're actually running on this. And if you remember, our switch is running Telnet, so we can potentially get the version of Telnet that's running on the system itself. And this is actually, it's SSH on the switch, apparently. Oh, I did the router. That's why I wanted to do the switch. 253. There we go. But now we accidentally have the version of SSH, and we have Cisco SSH 1.25. If I know the exact version like that, that is the point where I go to Google, flip open my phone, and I have an actual internet connection, and say, are there any open exploits for Cisco SSH 1.25? If there are, I can absolutely use those exploits to gain access to that system. However, with simple protocols like SSH, you usually don't find anything like that. And now, this is excellent. So, Cisco router telnet D, that's really, really basic, and they don't actually give us a version of this. However, this part is super interesting. Remember, I said that HTTP is probably the first thing that I would attack. Note, Cisco iOS HTTP config 1.0. That is the first production version of that HTTP server that Cisco has implemented in something. How often does any programmer get something right the first time that they actually put something in? Never. I guarantee that there's some kind of opening in there. So at that point, iOS 12.1, meaning that's probably what the switch is actually running as well. That is super, super old. That's like 12 or 13 years old at that point. I would Google the heck out of that and see if I can find some kind of opening in that. But again, we'll look at the actual HTTP piece here shortly and see if we can find anything open on that specifically. Once we get to the actual brute forcing piece, we'll do that right before the brute forcing. See if our port scan is open. Nope, still not. So again, a large scan like this, even just with a simple network, takes forever. So I'll leave this running and see if we get any actual information. We may find CDP running as a service on this PC, or the router. We may not. We'll see. We'll leave this open while we talk about the actual brute forcing pieces. See if we can get to that real quick while we're waiting. So, brute forcing. I said that the main thing we're going to be talking about is the actual brute forcing piece of this, because that's kind of what you guys have been talking about in the CCNA security class. Specifically, what we're going to do first is what's called MAC, essentially is a MAC flooding attack. We take every single possible MAC address combination and spit it out of a single switch port or a single port on a computer. What we're going to do is we're going to essentially overrun the MAC address table on a system. What this usually does, especially on older devices, most older devices only allow 32,000 or 65,000 MAC addresses per table. They've only got 64K of memory in the actual MAC address table, something like that. If we fill that table, it will then start spilling stuff out the end, and if it can't spill stuff out of the end fast enough, we will essentially say, you know what, I don't even care about MAC addresses at this point. I need to focus on my job of getting network information from here to there. I'm just going to become a hub. I'm just going to forget about MAC addresses altogether. I'm just going to start broadcasting information out. Again, I tested that on this, and we should be able to see that information with those loopback plugs that are acting as basic layer 2 devices, really stupid devices. It should work on this, but keep in mind that that is a 2950. That has been end of life for like a long time. I can't even tell you how long, probably 9 years. Cisco has not even sold that device, and it was not a new device 9 years ago. So, usually doesn't work on production things, and that is a really, really easy way to get shut down. You guys have looked at the switchboard port security where you only allow a certain number of MAC addresses. 2 or 3 is usually the recommended amount, so by issuing 65,000, that would certainly trigger something, right, if you've got that security in place. But again, a lot of people don't forget that basic security aspect. They don't actually include a lot of that basic stuff. So, something like this, we're just going to look at what actually happens with MAC flooding. And then we're going to look at Hydra. Hydra is, again, the application that I've chosen to actually look at the brute forcing of logins. Really, really simple. It works with a ton of different services. FTP, SSH, Telnet, HTTP, LDAP, TeamSpeak, anything you essentially can log into over a network, Hydra works for. There are other programs that exist, same exact kind of concept. I just like the interface of Hydra a little bit more. Their switches make a little bit more sense to me. So, you can certainly use the others that we mentioned, and I have another list in here shortly, but same kind of idea in between the other pieces. So, this command, hydra-v-l users.txt -p pass.txt -t5, specify the protocol, // and then the IP address that you're actually scanning. The V specifies being very verbose, the capital V being the very part. You can do a -v, little v, and that's just a basic verbose, but I like seeing a lot of different things for this. This is useful for debugging. If you see a request denied or a connection closed or something like that, that'll tell you some basic information about whether or not they've actually closed the connections on you. If they've limited the amount of connections or something like that. So I like seeing that information with the verbose piece. L specifies the actual list of usernames to use, so -L, capital L, and that's the logins that you're actually going to be using. We'll have a list of usernames in that actual file that we'll use. P specifies the file of passwords to use, so we'll have a list of passwords as well. Basically what it's going to do is it's going to take every username and cross-check it with every password. So it's going to take the first username, try every password in the password file. The second username, try every password. Take the third one, try every password. So it's going to sequentially go through all of that information, see if we can find anything that works. The T specifies the number of concurrent attempts. This is very, very easy to overdo. I talked to you guys about the limiting the number of sequential logins or failed login attempts that you have in this. That is, again, a very, very easy way to thwart an attack like this. That T kind of backs this off. I can only do 1 attempt at a time, and I can put a timer in between those. So I can say 1 attempt per 30 seconds or something like that. But me having to try potentially 10,000, 10 million times to actually find something that works, chances are I'm probably not going to get through something if I actually limit the amount of logins capable on something like this. And then the actual service, // is actually necessary, and then the actual server that application is running on. So in this case, our 254 is what we're going to be running on this on. Probably our 253 as well. Medusa and Encrack are pretty much the same thing. We talked about John shortly. John is a little bit different. Aircrack is very similar. It's just for wireless brute forcing, and that's a whole different day that we'll talk about. We'll get into all of those different things. And John can do the same thing for local files, so not over a network. We can look at like SAM databases or something that we can actually grab off of an actual system. If you gain access to any physical system, make sure you download stuff like that. If you want the local administrator account on a computer, I can't tell you how many times the local administrator is the same password as a domain user somewhere. And so you can grab that password. If you can figure that out, then you have a domain credential that you can actually use across the network. Really cool stuff, if we can find all of those. So let's look at these. Let's see if we can make these work. And finally, my other scan is finished, and it didn't find anything else. All it tells us is that 22 is open with SSH. So all of those ports, and it took over 5 minutes, almost 6 minutes to actually run those. So didn't find anything, but if this were a production thing, again, running a weird piece of software somewhere, a weird service, it may have found something actually. Now, at this point, direct your attention to the front of the switch. My computer and the router are the leftmost ports, and I've got a couple of loopback ports sprinkled throughout the switch. What I'm going to do is that mac-of command, the mac flooding command for this. I'm also going to issue a ping to the router, 192.168.2.254, and you'll see my light and the leftmost light blinking right now. Just a basic blink for each ping that happens. Note that the ones on the right are not blinking, at least not usually. You may see a broadcast in there every once in a while for basic things, but normally you will not see a blink, not very often at least. With a mac-of, well, I don't actually need a sudo, mac-of, this will literally sequentially spit out MAC addresses out of whatever interface that I have. Note that my lights are going crazy on the front of this at this point. And at some point, you should see the other lights, the loopback plugs that are not computers, blink, because now we are essentially turning this switch into a hub. We have overrun the MAC address table. This will work and not work, again, depending on the device that you have and depending on how fast your switch can become a switch again. It'll only become a hub if it can't actually keep up with the amount of MAC addresses that are being spit out. With this computer, it's a 100 meg interface and it's just a little dual core 1 gigahertz computer. So I can't actually produce MAC addresses very fast. I can't actually spit these out very quickly. So this would work better with a nicer computer, but for proof of concept, and you should, hopefully the loopback plugs are blinking, they were earlier tonight. This is a basic concept of how you might overrun a switch. No, nothing? Okay. Because it worked earlier, I promise. But again, only works on certain devices, and I haven't seen it work on anything within like 10 years production. I'm getting some now? Yes. Okay, excellent. So you'll see them every once in a while, but again, the switch will catch up. It'll remove enough entries that it'll become a switch again, and then it'll back off and start doing the hub thing. This would work a little bit better if we've got actual network traffic moving across as well, because I've only got the 2 devices.
The router and computer lights are blinking simultaneously.
Yes, because I'm actually pinging the router across, so it's broadcasting all that information across essentially. Because I've still got that ping going in the other window now. So stop that ping and stop the macOV. Get all that piece going. And now we'll wait for that to all calm down. Let's fashion up our Hydra statement based off of this. And I'm going to use a cheat sheet because there's a big command for this. And so again, the command is Hydra. I like having it verbose so that I can actually see this. Actually, before we do that, let's look at my usernames file. That is users.txt. I have a blank line which specifies no username. Administrator, root, user, and admin. These are all the usernames that I'm using. Just 1, 2, 3, 4, 5 of them if you count the blank line. So not a whole lot of users. And then I have passwords, and I have a bunch. I have blank, password, root, tor, admin, administrator, Cisco class, and then finally the weird ones at the end, aardvark and echidna. Those are my actual passwords on these actual devices, so that we can see what it looks like when they actually work. And hopefully you've got weird passwords on your stuff at home like that as well. And so I recommend not using Cisco password class, all the basic stuff.
You recommend using those two?
I mean, you can if you want. It's aardvark and echidna work. I mean, who's going to guess echidna? Everybody likes Knuckles, but not
everyone now.
Password, right? So, -V, -L for your logins, users, -P for the passwords file, passwords, and then the service that we're going to go after. And let's do telnet first. Let's do telnet on 2.253. So it'll be telnet 2.253. That's not going to work. Colon 192.168.2.253. Now in this case, I don't actually have a username set up for telnet, so it'll probably break in this pretty damn quick. If I had to guess, we'll see. But it may not actually work. It may confuse it since it doesn't actually ask for your username. Now at this point, I did not specify any number of tries. I have 50 total tries here, 16 of 50, and it's just going to run through them as fast as I possibly can. Again, that's a really, really easy way to get caught, and obviously the switch is taking a long time to actually respond to this. That's why I usually recommend limiting it to 5 or 3 or 4 or something like that, so you don't overrun the device, because otherwise this is going to take forever. Let's cancel this guy and do -T for that timeout. Is it capital T? No. 5. And that is 5 passwords at a time, or 5 concurrent attempts. So let's see if it tries again, although it may have already freaked it out. We'll see. See if it'll actually run. But again, with that telnet not actually requiring a username, it may not actually get it. We'll see. Since I specified a usernames file, it's going to try the usernames that exist.
What are the numbers to the side? It says child 4 and then 0/0.
Those are processes. So it's actually running 5 concurrent login attempts. So it's issuing a telnet connection 5 separate times. 0, 1, 2, 3, 4. So 5.
No, what does the 0/0 mean for?
Oh, those I don't know. Okay. I have no idea. I would assume that those are process IDs. An actual, like, if it gets any kind of information back for you, it'll report back in some fashion. Then we've got, there we go, 5 more that have them. This is taking forever. So let's screw that mess. Let's go to our router, and we'll do the same thing. Users.txt, passwords.txt, 5 concurrent attempts, and I know that the username is admin, and the password is, I think, aardvark on the router. And we can see if this guy works. And that'll be 5 concurrent attempts, and since it's a newer router, we should see it working on this. It should run pretty quick in those individual attempts. So there's 5 there. And there we go, 3 more.
0,
There,
3, 0.
13 more. And then it's just essentially running through. There's administrator, but then here's why I like the verbose piece. Terminating, cannot connect. So it is kind of skipping through a lot of this individual pieces. But it's still running through. It's retrying all of these. So user with a blank password, user with administrator, user with Cisco, class, etc. So it's running through all of these different pieces and trying these. If we find that one that works, it should be very shortly. Maybe not. Maybe not at all. So we are getting some errors across this. Nope, nothing worked. 0 valid passwords found. So let's see if we can. What is this guy? See if I can kind of point at this. Run. Make sure that I actually have the password set. Oh, and of course it's encrypted, so I don't actually know. Let's, I don't think this is case sensitive, but just in case, let's do a capital A, just in case. And actually, let's move him up top, so we don't have to wait quite as long next time. Shift insert, and then select yes, and try that same thing and see if we get something. Because it should be a kid now. Nope, still. Can we get an actual, like, fail on this? Nope, still nothing. Man, that sucks. I'm probably scared with the Mac-F thing. It's creating so much traffic on this. And so, well. Normally, if you get a work on this, you would get a highlighted green aspect that says this username and this password worked on this system. And this totally worked earlier, I promise. And this did actually work on this system. I tried it. Of course, I guess I pasted the configs again. This may not have actually worked. Let's see. Make sure that I actually pasted the correct password. Yep, it was aardvark. Aardvark is totally the password. I don't know why it doesn't work. Oh well. It's okay. So this would work normally under regular circumstances, but I would not doubt that Mac-F freaked everything out because again, it's going to overload Mac address tables with all sorts of weird things. So we probably got strange things happening in this actual network. With that, I've got 9 minutes left. Let's skip through a couple of these and let's talk about some basic things here. Running short on time. Hey, no, computer. There we go. So, denial of service. We won't actually do these because I won't show you guys the video, but I'll tell you about the basic things. There are a bunch of ways to issue a denial of service attack. There's a bunch of different ways to actually accomplish these sorts of things. The oldest and probably the coolest sounding is a ping of death, essentially sending a large enough ping to actually reboot a system or freeze a system. It doesn't know how to respond to a ping that is that large. Sounds really cool, but again, doesn't really work anymore. We have measures in place to say, hey, that frame is larger than it should be, just drop the frame. We're not even going to respond to a lot of this. So nowadays, ping of death doesn't actually work. What we can do is issue a whole bunch of pings that are the maximum available frame size. So by putting 64 kilobytes in the actual data frame header of an individual frame, we can send that frame over and over and over and over and over and hopefully overrun the actual network transmissions of this. Doesn't really work unless, again, you have a really, really fast computer. The command for that is hping, and that's part of a utility, a suite of utilities called hping3, where you can actually get multiple commands off of this. So, flood essentially says, do it as fast as you possibly can. D is specifying the data size, and then the host of the actual target that you're pointing to. ARP poisoning, which again will be covered in another presentation that we will do. Essentially, you're man-in-the-middling something in between, and in order to actually man-in-the-middle, you enable routing so that it's actually moving traffic in between you. To denial of service while you're ARP poisoning, you just don't enable the routing aspect. You don't say, traffic go through me, you just, hey, I'm the MAC address of your router, and then just don't do anything. You just don't forward their traffic across. So that's actually really easy to do. And that's done with the ARP spoof command. If you want to do the entire network, it'll actually listen for all ARP requests and respond, hey, I am this IP address that you're looking for, and will essentially ARP spoof the entire network, or DOS the entire network. So be really careful with something like that. If you're doing them on your own network at home, that will break all sorts of bad things. Now, this method is pretty controlled, but it does only work on a local network. Again, ARP is limited to the actual local network that you're plugged into. So it won't work on everything. There's also SYN floods, Smurf attacks, firewall hijacks, all sorts of different other things. The one you hear about with Anonymous using all the time is a SYN flood, which essentially says, remember, TCP handshake, SYN, ACK. We're sending TCP requests so that the server has to respond to whatever that is. So the server has to generate a response to an actual piece. That takes a lot more processing than does normally. We can also do a Smurf attack where we essentially generate a SYN flood with lots of different clients. So we can actually say, all of these clients talk to this individual host and request a SYN packet. So we can actually generate a SYN flood attack from a multiple piece, creating a sort of retro botnet kind of thing. Really cool stuff. That stuff takes a little bit more setup than we have here. We may talk about it at a later date, but does the same thing. We're trying to get rid of network access at some point. Now, again, skip the demonstration piece, and we'll talk about this piece real quick. So I only got 5 minutes left. That's about how long the video is. There's an old saying that goes, if you can touch the device, you have access to whatever information is on that device. That is super, super true. There's nothing truer in IT. If I can touch whatever device it is, there's a way to reset the password or gain access to that actual device. Be it reset with a hard reset or password recovery on a Cisco system or something like that. There are so many ways to actually gain access to all of these devices. And that's why I think physical security is really, really important to talk about with network security nowadays. Network appliances can be broken into a password recovery. We all forget our passwords. There has to be a method for recovering after forgetting a password. That being built into all sorts of systems, we can obviously exploit that. That may require us to reset configs, or depending on what it is, if it's an older Cisco device, you can actually look at the running config by booting to a ROM prompt. You can actually show files that exist on the flash. That's actually existing in most Cisco devices still. So we can actually look at configs without even having the password for that. We just shut the device off, get it into a ROM prompt, and we can look at the running configs, potentially getting passwords for all of these sorts of things. BIOS security can be bypassed in almost any way. Jumper, what have you, button on the motherboard, whatever. There's a way to get past BIOS passwords on local Windows systems, on local hardware systems. Windows security is a joke. The same password tools work on everything from the old 9X stuff all the way up to Windows 10. Same database cracking tools work on all of these individual pieces. They still keep all of their passwords in the same databases. Now, with Windows 10, you do have the remote login piece where it actually uses your Hotmail account. That kind of thwarts that because you need an online piece. It will, however, locally cache your credentials so that you don't have to have network access for those. So it kind of thwarts itself by locally posting your credentials. And then, once you get that, you have the person's Hotmail account. Then you can get access to who knows past that. Linux is even worse, unfortunately. The user's password is blanked essentially in the etc password file. There's categories for those of you who've been through the Linux file. If you take away the X that exists in etc password, it treats it as if that user does not have a password. So you can literally say root, and then it'll just let you in without actually asking for a password. Super, super easy to do. I don't actually know how to break into Apple devices because Apple devices are not really, you can't find them anywhere. However, they're exactly the same thing as a Unix system. They actually have an etc password. It's just not actually stored in etc password, but it's the same exact format. And you can go into the single user mode with the Command R piece. That'll actually get you directly root access. It's essentially a safe mode that gets you a single user prompt for this. And that gets you a command line, which is plenty to get into whatever you need to do. So, almost as easy as Linux, just a little bit different because the syntax is weird. You just can't find apples near as much anymore. And the only real way to combat this problem is to physically secure your stuff. Have it behind locked doors, have it encrypted, have it somewhere you can actually keep people from getting to it. That's why physical security is becoming an up-and-coming thing, even in network devices. People are still idiots when it comes to security. I cannot tell you how many passwords I've found underneath mice or keyboards or on desks or what have you. Somebody writes their passwords down somewhere. Walking down a hallway of any organization, I guarantee you could find an empty room somewhere that's not secured, walk in, lift up a keyboard, do that 4 times, and I guarantee you would find a password. Somebody has one written under a keyboard somewhere. So many people fall victim to this. Offcrack is a basic utility that runs a rainbow crack table. This was essentially brute forcing with a compressed table, which allows it to run a lot faster. Same kind of deal, but you have to have it on a local database, so similar to John, the utility that we ran before. And there's a video that has resonated with me for a very long time. This is Johnny Long. He did a presentation in DEF CON 15 that I absolutely love, where he talks about different physical pieces and how to bypass a lot of these different locks. This is a really, really cool video. I love it.
Master lock? No, did somebody say none?
So which of these locks is the most?
All right, well, let's work on none. How do you break this one? Very good. With a pen. Here's the proof. You guys have seen it. 3, 2, 1. 3 seconds. With a pen. How do you break this one? You gotta think less technical. Shims are a little bit technical. Not bad, not bad. Think one-handed person with a deficiency could do it, right? The flosser, right? I've seen it before, here we go. 3, 2, 1. Whoop. And there it is. All right, how do you break this one? No, not pen. Are you making a gun? You shoot it? Oh, Mork and Mindy, right? Oh, so. No. Here you go. You ready? Can I get a shout out for Tool, please? Because Tool rocks, man. All right, here's Barry's answer to popping this lock. Barry at Tool. Cut the toilet paper roll, get a little piece of it, cut it out of the corner, wrap it into a little cylinder, and
stick it in the lock. You twist it a little bit. And open.
Toilet paper. Tool rocks. All right, how about breaking this one? Beer can, maybe it's still like a shim thing though, right? All right, pen and paper, you're getting close. How about this? Yeah, possibly. All right, most of you have seen this. I'm not like preaching to the choir, but it's relatively simple. A lot of these locks, you put a little bit of tension on it, you pull it until it starts to catch, and you move it back and forth to try to find sticking points. Like this one sticks at 1 and 2, which makes the point in the center 1.5. You do this all the way around the lock. Here's a sticking point at 7.5 and 8.5. Sticking point in the middle is an 8. So you take these numbers, you run them down. Here they are on the right-hand side of this table. You write them all the way down across the entire lock, and you get these numbers. Get rid of every number that's not a whole number, because they're decoys. Get rid of every number that doesn't end in the same number, in this case 8. You're left with one number. This is the last digit of the lock. All right? A little mod 4, you get down to 100 or less combinations on the next 2 digits, or the first 2 digits. Estimated time for breaking this lock, less than 3 minutes. With your fingers. All right? There you go. Now, the push button lock. My favorite. It's just a design flaw, you know? A lock where you have to push buttons in front of other people. All right, so I decided this is just too easy. So I'm going to find a lock in a place that's a little bit sketchy, all right? Where I could probably get busted lots of different ways, and I'll see if I can get the combination anyway. So I went to the airport, sat by the pilot's pre-flight door, and waited. All right, ready? See if you can catch it. Design flaw. So put the camera around my back. Here's a little shot of his butt. Here's me shoulder surfing the pilot. And this is what they call the money shot. This is the shoulder surfing plus the badge all in one picture. It's a problem. So the answer is to update your policies. Never allow any of this into any building that you work for.
If anybody's interested, Johnny Long does several DEF CON speeches on different presentations on a lot of no-tech hacking, he calls it. Really cool, easy, basic stuff like that. Again, things that you wouldn't necessarily think about. There's no way to get into a tubular lock without a special kind of pick. Certainly, if you do it enough with a toilet paper roll, you can absolutely fall into that certain combination. So those sorts of things are really, really helpful. And don't look at security as a way to stop people. Look at it for exactly what it is. Be a hacker of sorts in these truer terms of what they used to be. Absolutely.
Oh wait, you're talking about your projector's not even locked up. Seriously, man, we're like, look, it's down there on the floor.
Based on the number of sticky points on a combination lock, there's only so many that actually work. So you can essentially eliminate a lot of possibilities just by moving the lock back and forth. With some math, you can figure out there's less than 100 combinations on an actual lock that may work. So just math, trial and error, brute forcing a combination lock. Yeah, well, I mean, it takes a little while, but yeah.